Ah, what a shame. I didn't see the chat. Yeah. Thank you, Coffee Lover. Yeah, so my laptop died. So I was booting it up while I was still trying to. But anyway, I'll briefly explain what I was saying. So I think the problem came. So the stream crashed because I think the GPU crashed and it might have brought down OBS at the same time. So I think that's why the stream crashed. So the next problem is that I'm still bump allocating the sort entries count. So when I go and dispatch compute shaders afterwards, well, it's dispatching more thread groups than that will end up indexing into the sort entries buffer. So what we need to do is actually do a min tile bin so we'll just min it, yeah, with graphics tile bin entries capacity, and then we'll make sure that we actually store it back out. And I think we've got to do that on the other one as well, the bin one. Okay, so that's great. I've got to make sure inside the find ranges when we dispatch it that we are doing read write instead of read only on the global buffer. Got to be super careful there. So in the bin, so when we bin, I don't think there's any special. Right, so after we've splatted all the oh no, these splat objects are gonna need, hang on a minute. So before the splat objects run, there's a setup shader, isn't there? Here we go. So there's these next indices. This is how many tile bin objects there are. We've got to make sure one for each bin. Good, good, good. We'll do the same thing. Or a similar thing. We're going to min itself with graphics tile bin. I think this one is objects capacity, right? There's 256,000 instead of 4 million. Because these splat objects are going to duplicate references to the objects that we want to bin. And those need to be capped because if not, they will fill up the dispatch indirect args and then too many shaders get launched. So I think that's the next problem. Let's give it a go. All right. Oh, we hit it again. Oh. I think we just had a slow shader. Interesting. Come back. Come back. Oh, these frames are taking way too long. But they're running. I think that's alright. Am I still here? I think I'm still here. Beautiful. Where does that camera there? Okay. This is interesting. Why is that warning me? When I thought we capped it, right? Oh, so maximum 16 million actually on the sort entries. That's way too big. Okay, that's interesting. So what are we doing here? Do we use this in any other place? Because it's saying that was big, but if you look at the number, it is capped out at 4 million. So the capping is working. It's just I think we're somehow having access to more. Right, well, how does the sort... So sort... Graphic sort... So I think it's a sort indirect with payload. Right, it uses this guy. And... interesting. We don't do the clamp here. Right, that's a bit scary, isn't it? So the clamp got done in find ranges, which is actually too late. So we need to do... Of course it is. So we need another shader here, which kind of sucks, because I wouldn't... I don't like the fact we have to do another shader. We could do a thing where we write in... No. We have to do another quick shader. Let's put this back to read only. Oh, okay, let's copy this. I'll make another one called... Maybe like this one. Tile bin sort setup. And we're going to do a... So we'll just make one of these shaders. This needs to be read-only now on the global buffer. And so where that find ranges is... We shouldn't do it here, unfortunately. But yeah, we'll copy paste this. So it's called like sort setup, tile bin sort setup. Just launches one thread, right? It's not the best idea to do this all the time, but you have to do it. Because the problem is you put barriers down and it's just a waste. You have no compute units running. Other than this one, doing one thread. So... I didn't know bundle constants, didn't know. Because we're just using the global buffer. So we read it in, minute, put it back out and do a print. Cool. Okay, so I think that will be the fix. So the problem is it was trying to sort far too many objects and it was actually doing it. And that was causing it to be such a big time. Maybe. Right, this is good. We're reaching some capacity here, and now we're just getting glitches, which is fine. This is 10 milliseconds for this frame. That's okay. That one's 18 milliseconds, I don't know why. But yeah, so we're getting... It's interesting how the ones at the edge of the screen show up, but the ones here don't. I did disable the occlusion culling, by the way. So we turn it down to a sensible number where things don't overflow. It's like, hey, I can render these. There's some point... So if we just open up a calculator, we can figure out what this is. So 23 times 23 times 23, that's 12,000 models. So times 27, right? Because we've got 3 times 3 times 3 of ellipsoids per model. That is 328,000. Now we had a limit of 256,000 objects, right, to render. So we've already gone over that here. And then we've got like a million objects. So yeah, I guess we've got to be careful with the number of models we're allowing here. But we're trying to stress test things, right, and test performance. So we're going to start seeing like glitches and things. But in terms of... I've disabled the occlusion buffer. And surprisingly, that's only 16 milliseconds. I don't know how many objects we've got here. There's quite a lot, right? Maybe there's some small ones at the back. Let's put the occlusion buffer back on. That actually helps with performance, which it hasn't been. But yeah, so it went down just a tad overall. Right, when I come out to here, it's like a big problem. And maybe it's because we can see through things more. I don't know. Oh, for crying out loud. Oh, this is the profiler running out of memory. I just bump allocate into a static buffer. This is the way. So yeah, it's interesting. Maybe we should limit to 32 on this slider, I don't know. Yeah, the occlusion buffer needs to be... Right, so maybe we can just start simple. Yeah, right, so we need another piece of UI to say like how many instances there are, how many ellipsoids, and then how many overall ellipsoids we're trying to render. That would actually be helpful in this testing. So we'll do that sort of slider UI. We're just going to do this. Sorry, we already have the number of ones here. Maybe we could say times that times that times that equals this. Or I could do cubed. What's the tiny 3? It's not really ASCII though, is it? Not going to show up. Oh, I've got a cube function. Look at me go. Cool. That's a few ellipsoids, yeah. Just a few. Just a few. How's it going, 10th bar? Welcome, sir. Oh, I need to do this thing as well, innit? Ah, yeah, but I didn't copy it. Oh well. X. Right, then this final one will probably want to be the total number. Total ellipsoids is equal to. So we're going to take the number of. I guess it's just the cube of that multiplied by the cube of this. So much multiplying. So that'll be helpful when we're actually trying to look at numbers and things. You don't have to calculate ourselves anymore. So we've got 1. Oh, I need to make this bigger, so 200. Maths. Oh yeah. Alright. So that's 97,000 ellipsoids. And to render all of that apparently is 4 milliseconds for the models, and that's without any occlusion culling. I don't think it would be that good. It's quite right, isn't it? Why is it that good? Because if I move out, it's sometimes that good, isn't it? Sometimes it's 8 milliseconds. Because when I move out to here, it was getting a bit of a problem, wasn't it? Sometimes. No, it seems okay. Full screen worth about 5 to 8 milliseconds. So the ray tracer is a bit noisy. Sorry, the ray. It's everything. Sometimes it's a bit noisy when it. Is it because I'm filling up the cache? And therefore it's. Yeah, I don't have a theory on what it is yet. A definite one. I've got to think about my renderer. I don't know what's making it so noisy. Because there's a certain point. Yeah, okay, so I don't know if it is something to do with the cache because. No, we're not. Because I want to make it small ellipse. Yeah, what would be interesting is to look at these numbers as well. So when the ellipses get small enough, they do get discarded. And I wonder, is there the... Oh, for crying out loud. There's UI on top of UI. My life. What is going on? Can I not access? Oh, I can. Good. The occlusion texture is just white. Perfect. Meaning that... Right, so that's definitely not impacting this. So... Right, sometimes it's quick, in this case. Really quick, and then it's like mostly long. So maybe it's like when it just gets long enough, it's actually got a fight with OBS for time slicing, maybe. And maybe because it's like this short, the time slicing is a bit fairer, maybe. But I I don't know how I can test that theory, you know? Now, why is it this noisy? It's easier to blame other people, you know? But it could be something to do with my code. It's probably more likely something to do with my code. I just don't have a theory on why at the moment. This is something we want to think about. That seems quite alright, doesn't it? 125,000 full screen, let's say. We can definitely make it better though. 4 milliseconds to do the ray tracing. This is without any occlusion culling. So it's sorting them into screen tiles. We could get a number of how many. But to sort those, all of them. Right, let's look at some other numbers. So we've got the occlusion culling disabled, right? Gotta be careful here. The number of ellipsoids that we render ends up being a little bit less than 125,000. That's probably because some of them are so small, we've actually faded them out. I think I've got a bit of code in for that now. So they get hold based on that. So in terms of the number of... Yes, the number of objects that we are splatting are here. And then we end up sorting this many. So we add up to 4 million, right? So that's okay. We're not overflowing that buffer there. These ones support up to 256,000 each, so they're not obviously overflowing. There's no overflowing going on with these, and cause them random ones to render and other ones not to. Alright, that's the profiler filling up. So, yeah. I wonder what happens if we had like perfect occlusion culling without doing a second render. How much does that help? Maybe it's something we can look into testing out. Like, I wonder how many we can push. So yeah, they go off the screen. Oh, there's also a far aspect to it, isn't there? Right. Yeah, when they, let's disable the occlusion culling. When they go far enough off the screen, they can also get cold as well, like too far back. Right. Let's bring on the profiler. So it's strange about the noise. It's hard to know maybe without a proper profiler from AMD maybe, you know? What's going on? Like where's the time slicing going? Is there any time slicing going on with another application? Can we somehow Linux GPU profiling? Is there a way? API trace. Well, I want to know. I guess I can check off stream and see if I disable OBS. You know, when I quit OBS, does that still flicker, you know? So I guess we should write down See, the thing is, I can't really have perfect occlusion culling here because there's holes. And those are pixels to the background. So if I was to take the depth buffer from this frame and then use it in the next frame as occlusion culling information, when I downsample this, it's not going to actually do anything that's useful because it's gonna... Yeah, the only time it will be useful is when I do edges like this and you don't see any down from a corner. And you don't see any holes. Yeah, that's not good, is it? Occlusion buffer doesn't work. It's incredibly wrong. Oh my days. Right, so even that... Okay. Maybe it's the feed... Yeah, that's not sure. Yeah, so we should test taking the sort of the perfect depth from the previous frame. Yeah, that doesn't look lovely. And seeing if it helps with the performance times. Because I think doing a whole render before is just not possible. We should still keep the code around though, that is for sure. We might have to do... Just use the depth buffer from the previous frame and maybe do a bit of reprojection and some cleanup of the image. And live with the... And hopefully avoid all the artifacts, because I think for this game, we are not going to have that many... The camera's not going to be moving that fast. So I think we can live with... I think we can get away with a lot. I wonder if we can have a bit of a play to do that now. Yeah, let's just see if we can do that now. We might need to have... So when we say sort of like occlusion, render occlusion buffer, that is like recreating the occlusion buffer if it's changed in size, right? And then it does a whole ray trace, right? So maybe we just make another one. And we call this one like prepare occlusion buffer or something like this. And all this one's going to do is, I think it'll do a full screen resolution. And you might recreate it and do a clear or something like this. So it's equals the scene dims if that's changed. Calculate the number of MIPS reinitialize, clear. I think you can get rid of all this then. Right, then later on I think you can do a copy basically. You can potentially do some kind of like copy with the occlusion buffer. So at the end of the frame you take the depth buffer, copy And all that that's going to do... Do we have a texture copy? I do. But how good is it? Is it really like what we need? Because we don't want to copy... Right, so yeah, you can copy the whole... Right, it only does the first layer and first MIP, which is what I wanted to do anyway. Right, the occlusion texture's got like a full MIP chain. But yeah, this is all I need. So... Right. GPU texture copy. Copy. Destination. Occlusion texture. Source. Depth texture. Yeah. And I think the rest can all just be zeroed, basically. Yeah, if the dims is 0, then it will just do all of it. Yeah, the dimension 0 it just does it all. So that's pretty neat. So I think we can take this, and then at the end of the frame, so render frame, or render occlusion, let's find that quick. So instead of this, we'll be doing, for now, let's just we'll do prepare instead, right? So just reinitialize the occlusion buffer if the screen resolution has changed and clears it. So it won't be effective this frame or something like this. I want to do a downsample, isn't it? As soon as you do a downsample. So then at the end of the frame when you've done the last render into... Yeah, so at the end of the frame really probably after you've output something to the... so yeah, before submit. The final thing you want to do yeah, really you could... I don't know where you want to stick it, to be honest. So you could probably say graphics, copy depth to occlusion buffer. And then in prepare, where's the downsample? Here it is, yeah? So if it's enabled, and I guess it wasn't... I guess we'll do this. So, sorry, a similar thing to this. So if it's enabled, we just want to do a downsample. And we've already got the depth from the previous frame inside the base MIP. And then if not, we're going to clear it. And so let's take a look at that and just see what the performance looks like if we was just to have the sort of the perfect depth buffer, because we're not going to move the camera. And we're also... Right. So and if we see any glitches, it must be to do with the way the code is the sampling rather than... Well, I don't know. We'll see. So we go to the occlusion texture, my face. Okay, that's not helpful. Why do I not see... Is it because I'm doing... What's the problem with the depth texture? Do we write to the depth texture? We should do, right? Oh, you bugger. So after 3D render, it clears it again. Okay. just give that a... So before we overwrite it again, withdraw 3D for some reason. So I guess after we render models, we'll do a copy depth just there. Cool. Right, let's give that a go. And take a look. Okay. Right, we're still seeing some glitches with the occlusion texture actually, which is a damn shame, but... So the occlusion culling. We got holes. Yeah, so it's going to be... That's interesting, there's holes in the depth. So let's look at the depth. So disable the occlusion culling there, and if... Right. So there's actually some holes in the depth texture. We should probably look at trying to... That should not be the case. There's something weird going on with the anti-aliasing shader, I think, to the point where it is not reporting a hit when it should be. So those are something to look into because those will ruin the occlusion culling. And maybe that's what's ruining the occlusion culling here, because they get minned. So go back to the occlusion texture where we... Where's the downsample? Oh, there we go. So, yeah, I don't know why that one's... It should never be rising back to 0 here. I think we've got a bit of a bug there. And then these things just will expand and expand and expand, causing holes, and then more things end up getting rendering. So, yeah. And I think there's something wrong with the sampling. Yeah, something a bit dodgy going on with the sampling as well. Or is it because it's copying? It might be to do with the fact that I've made it a power of... I had to make it a power of 2 so the downsampling would work flawlessly. Any problems? You know, if I can take any of these numbers with... Doesn't seem to be having much effect with here because it's just so buggy, I think. But yeah, so I wonder what that bug is with the ray tracing. It's producing the... These... By the looks of the anti-aliasing, sometimes will produce a miss in the depth. So I guess we can quickly look into that. Ray trace anti-aliasing. So the way we go over... So we go over all the ellipsoids in the tile. They're roughly sorted front to back based on the near depth of the view space bounding box around the ellipsoid. We say if you've missed, sorry if you haven't missed, if the object is in front of us in some way, try and render it. We've got some sort of like anti-aliasing thing going on. And maybe that's 0. So this gets clamped to 0, meaning the alpha gets put to 0. No, I don't think that's a problem. So if you generate like so yeah, it builds up a hit list basically. And it support up to like 4 opaques or something like this. So when you sort of skim an ellipsoid, it will have some anti-aliasing alpha and it will collect it as a transparent object or a transparent hit. So you know, you've got this hit list. You do a quick sorting thing for 4 elements, and then you go over all the hits sorted properly because they weren't properly sorted per pixel, which they need to be. And then you do this sort of blending thing. So I'm thinking, right, the only time you hit this is when the alpha is fully opaque. So it must mean you never hit a fully opaque. It must mean you never hit a fully opaque object. So if that we was getting quite a few there. If you have something with 0 alpha, alright, let's just look at the depth buffer of that. For crying out loud, I've already done it now, haven't I? Anyway, let's look at the depth buffer of that. Right, there's a few little specs. Let's look at the proper depth buffer. Oh. So there's an edge, and then it's not hitting another edge behind that, it's hitting an opaque thing. There's an edge. So I can't believe, so if you hit a 0, and you've actually tried to insert a 0 into there, is that a problem? Not in this code, but I'm thinking later on. When you do a front to back blend, and you got 0 alpha, that's not going to be, it's not going to now forever be 0, is it? That would be weird. So if you're back, so you pre-multiply it so that just goes to black. Then what happens to the back alpha again? Right, then it's 0 times the inverse. Well, not inverse, but maybe you still call it inverse, I don't know. So they just get 0 basically, then you say plus the front alpha, right? So that will then mean that the alpha is still going to be something non-zero if the one behind it is fine. So maybe what's happening is that it treats it as a right, let's say that if AA alpha let's see if that fixes it. Depth. I face. That did not fix it. We still got these little specks. So I guess the only time we could is if we somehow get the exact pixel and print out for it. Print out something, but I can't figure out a way to do that with that. So I can say if the mouse is over the pixel, I can do that, but selecting out of all the pixels on the screen is quite difficult. And I can't know about it before I run this code. I guess the next question is it a tile boundary? They didn't look like they were tile boundaries. So I don't remember that or having that feeling about it. Oh shoot. Depth. Oh, that's interesting. That's because I went inside it. Ignore that. I don't think they're on tile boundaries because these are like they're neighboring within the same tile. It's only 16 by 16 pixels a tile. So it's bigger than this distance between two of them. That's not a thing. It's definitely always on the edges of something. So that means the only other line of code where there could be an issue is this one here, right? So only when final color. And the only way to exit this is by reaching this code anyway. Because it would either exit here or it exits after this loop, in which it will never hit anything else. Hmm. I could try and fix the camera somewhere, output all the texture coordinates. They have infinity and then look at those ones. Pick one, then do the special printout code for that pixel. That can work. What I really want to know is for the ones which have hits, which ones which have hit some ellipsoids, which which ones still transparent, I guess, and then print out that list. It's bizarre. It's 24 in it. Yeah. I wonder if this is ever infinity. The prints out yes. Then for some reason one of the depths is infinity. Right, I'm not seeing it, that line of code be run. We'll see it in here show up. So everything that hits here is definitely not infinity. So it's set some actual depth. So it means it's definitely not running this code like we expect it would be. So the alpha comes in. What we could say is just get the alpha from the ellipsoid. And then well, let's just say there's no alpha blending, right? This is let's just say there's one, because that's what it's going to get right if I get it from the ellipsoid. Do we still have that same issue? We must do, right? That's what I'm assuming. So let's check the depth texture. Yeah, so we don't have the problem here. So it's definitely to do with some form of alpha blending. The anti-aliasing. Like, so you get a hit. We've got up to 4 layers. This is the confusing thing about it. So I guess we could say, I think we've got some logic here. If it's opaque, sorry, if it's transparent and we've got a hit, it must be one of those anti-aliased ones because I don't have any transparency ones at the moment. So that's less than 1. This could be some helpful thing. It's not as helpful as other ones I could write if I had a better way of doing it. We could say, right, what is my hit index? And also what is my hit list entries? Or maybe from here on out we could keep maybe keep printing the next results or something. But so if there's only one entry and you've hit it, why isn't there more? That's going to be my question about this thing. Whereas this one has some, and the reason is because it's got edge pixels, right? Of course it has. But they're going to have one entry. That makes sense. But when you expand out to more, Right, these are as I would expect them to be, right? You have a hit, but then the rest of them are actually equal to such thing. Sorry, many entries, right? And so you would expect the ones behind it to be opaque, and it seems like they are, because you're not getting a H index of the same count. Maybe this one is the only one I've seen it, but the rest of them I haven't been seeing that. So although we didn't really go full screen on it. Let's go full screen and that'll give me a... Don't do that. Right. Let's just call it count. I think it's printed out way too much string information and then it crashes sometimes. So maybe the processing code doesn't handle overflow properly. Don't do that. Oh no. Right, do we have any instances there? Oh, there's some buggers here, that's the problem. But yeah, we see the depth. Right, we've seen a whole bunch here. It's not the best camera angle, but we've got these ones here we should hopefully... Oh no. Be careful. Yeah, they seem to be as expected, right? They're like... Mm-hmm. I'm curious, like, what is after this actually takes place? What does the final color end up actually being? Like, it should have blended fine. So, found transparent. We're just going to print out like, hey, what was that alpha? We want to say you found a transparent and the hit this entries count is greater than 1, because that will be the ones at the edge of the screen. We don't want those ones. Let's try looking at that. See if it's some of it like weird value. So I'm not seeing anything printed out there, which is great. It's 1. It's 1. So why didn't this trigger? There's no early exit here, except for here. I think it might be so close to being 1 that it ends up just failing. I don't know why. Sorry. I did see a 0.931 there or something like that. We should also say a final color is not. We should put it in this thing here. Let's try that. Hey, Drew, sir. What's the purpose for tonight? Well, we've been trying to prepare for. Oh shoot! I took a screenshot. Whoopsie. We are basically just preparing for a bunch of. Yeah, there we go. So I built this sort of like testing UI where we can build a grid of instances of models and change the model we're instancing to have its own subgrid of more ellipsoids. And the purpose is to test kind of performance on how many of these things can we actually render at what speed. So we set this up tonight at least where we can do that. And it's currently I'm just looking at the occlusion buffer and trying to use the depth buffer from the previous frame to avoid doing a separate render and help save some performance there, really. So this is really going to last the next couple of streams where we just test and tweak for performance and solving little problems like these and stuff like that. Solving any crashes for high numbers of instances, which we've done today, and other things. But yeah, they're still showing up, and we're seeing there's some alpha values, so these have something here, which is a damn shame. So I don't know why they're like that. What's listed here is less than all of these here, so maybe... Yeah, I'm confused about that, it's a weird thing. And closest hit is infinity. Let's see what the final alpha is. Let's try that one. Right, that's way more this time. This is more like it. So they're all kind of close to that 0.9999, kind of. So that's interesting. And that seems like the amount that we saw on screen, but some of them are actually like a lot more. Right, so I'm interested in like how such thing came about. Oh, it's this bit here, isn't it? It's the blend. All right, so you've put one of these on. So that will give you one take front. So your front was 0, initialized to 0. And then you put on a back with a bit of transparency. So at 0.5, say. So 0.5 times 1, right, plus 0, 0.5. So you're left with 0.5 in there. Now that's your new front alpha. So 1 take 0.5 would be 0.5 times the back alpha of, let's say, 1. So that'd be 0.5 plus the front alpha of 0.5, which should leave you at 1. But it doesn't. So let's use a bit of a different number. So this is like the epsilon maybe, but it's a bit weird. Let's try a bit of a different number. Let's say a 0.2 alpha. So the first time before we hit anything, it's initialized to 0. So the first back one will be 0.2. So 0.2 times 1, right? Is obviously 0.2 plus 0. And that will give you a result of 0.2. So now the next thing you hit is fully opaque. And that will take a... So the front will be 0.2. So that'll be 0.8 of 1, which will give you 1. Sorry, 0.8. Plus the 0.2, which will give you 1. So we should be expecting... But the thing is, I didn't know what all of the alphas were. So I think here what we would like to do is actually print out all of the alphas that are passed into here. And I think there's a problem with because the alpha's coming in through a packed thing here. So it's stored into 8 bits. And it must be that, okay. It might be to do with the packing. Maybe. Something like that. It's probably something to do with that packing code. So only when it's 255 does it. Actually go to 1. So maybe we want to round it up a bit. Does that help with the problem? Yeah, there's still these numbers are still showing up. So I don't think that helped. Depth. Yeah, the dots are still showing up. Okay, so that round up was not a good idea. Okay, so the next thing to do is that, well, we found a transparent one. Why don't we take all of the... Why don't we take the first 2? Well, I've seen it's like 2 or 3, to be honest. So why don't we just print out all the alphas? 1, 2, 3. So you got to go into the sorted hit list as well. Right. Okay. So let's see those 3 alphas. It would be good to know like a count, like the number of, I guess just put like the array index in there just in case that the third one is not really useful. We can actually see that in the print data. Hopefully, that's what we want. Yeah, we haven't got printing from compute shaders. It's just basically impossible, I think, to program anything. It's ridiculous. Okay, there's a 0.8. Okay, so it seems like, for some reason, that the ones that are showing up here at least, so twos, right, that third one, ignore that one there, because it's only these two. This one's got 3 of them, yeah? They're all kind of half transparent or something like this. They all seem to be apparently pixels, which are transparent, which doesn't seem to make any sense. Because if you actually look at them, that's a near miss, right? So that one will be transparent, but the one afterwards, that ain't a near miss. So it's weird. But maybe... So it's got multiple layers of near misses. Not believable. Alright, so I reckon what's happening is this early... Okay. Maybe it could be earlying out. It can't be earlying out. Maybe... See, I wonder if we disable the optimization code that I've got, which does the earlying out up here. Does it fix the problem? This earlies out if you get an opaque hit. That's right, an opaque hit. We haven't got an opaque hit yet. Maybe. No, we had an opaque hit. Let's try it anyway. It earlies out if you got an opaque hit. And figures out like, oh, we've stepped far enough to early out. So I wonder if that's still present. I think it is. Yeah, it's plenty. Right, nothing to do with that. So it's something to do with the fact that the list always has alpha transparent stuff, which is bizarre. Maybe the metric is just terrible. Maybe the dot product idea is terrible. Maybe. It's probably another way to do it. Yeah, perhaps this is just causing... After you get a hit, calculate the normal. Do a dot product with the array. And then dot it. Yeah, then basically when that's descaled, it's, you know, it's the anti-aliasing alpha. It's a bit of a hack, not gonna lie, but it's done the job when I've looked at stuff. But maybe it's got edge cases which it causes problems at. But we would see it if it's on a single ellipsoid if that was the case. And we don't see it. Oh, there's a one case there. So apparently there's one pixel which fits into this. Oh, there's more. Plenty. Right, so apparently we're not even checking them all. But yeah, there's one of these is this value here where it's got 2 hits which are transparent. But I can't. You know, I don't see 2 edges being hit here causing the problem. Let's see if you bring it back to 1. Scanning around the object to see if I can find any of those. I don't see any special sort of alpha things popping up. Well, no, but it would only say 1 hit, wouldn't it? And I've got an if statement here to say if it's more than 1 hit. It's got to be more than 1 hit to even show anything. Okay. Right, I'm not going to find that tonight. Okay. That's cool. Right, so I guess we'll look into this next stream, try and figure out what this problem is. Here the opaques, sorry, the transparent near miss is like basically causing these little holes in the depth buffer, which is a problem for the occlusion buffer when we want to use the depth for occlusion. That causes big issues. And yeah, we'll look at the occlusion buffer, see if we can sort of maybe reproject it and kind of get a more free occlusion buffer calculation, use the one from the previous frame and stuff like that. And yeah, just more performance testing and little fixes like these to make it much better and seeing how far we can scale things up. So that'll be on Sunday at 6 p.m. GMT plus 1. And yeah, in the meantime, guys, come hang out in the Discord and yeah. I hope you guys have a good weekend. I'll hope to see you all on Sunday. Alright, let's give Ryan another raid. Alright guys, catch you later. See you in the next